Hello there and welcome to another video on module 1. This will be our last lecture for module 1. In this we'll be discussing the shift operations as well as the arithmetic logic shift. Okay, this is also another type of operation and let's get to it. So first of all, what are shift micro operations? These are basically used for serial transfer of data. Okay, information is transferred through the serial input and it determines the type of shift. There are mainly three types of shift: the logical shift, the circular shift and the arithmetic shift. The directions of shift. So there are two directions. One is the right shift and the other is the left shift. So for the right shift, we are going to be shifting each bit to the right by one place. Okay, so each bit moves by one place to the right, and there will be a serial input over here. So depending on what sort of shift we are doing, there will be a different serial input, the number that we'll be inputting to replace the first bit. Okay, and the last bit will be overflow and it will leave the data. On the same In the same way, the left shift is going to be shifting each bit towards the left, and a serial input will be added to the lastmost bit, finally causing one of the bits to be removed from the data. Logical shift. So logical shift is a shift where the serial input, as we discussed earlier, there will be a serial input that will be added. The serial input in logical shift is 0. So whenever you shift, okay, whether it's shift right or shift left in terms of logical, you are going to add a 0 to the point where you're shifting it from. So if we have a right shift, all the numbers will be shift and the first digit is going to be a 0. You're going to push a 0, fine, and the rest of the bits are going to shift. Last bit will be discarded, and that's how it works. On the other hand, a left shift will be where you push left on the rightmost bit and the rest of the bits are shifted once to the left. Here is an example for a logical shift right. The notation is SHR, that means SH for shift and R for right. If we have R3 as our register with data 10110111, then we will be representing it as R3, where we store the shift right of R3. The execution will be giving us the following output. So we are going to shift all the elements once. We will discard the last one and the first element will be replaced by a 0. Since we push a 0, so 0 and then the elements until we reach the number of elements, the total number of elements. So 0 1 0 1 1 0 1 1 by overflow for the last digit. Logical shift left is represented as SHL, shift left. In this one as well, we will be pushing 0 on this side. This bit will be discarded and this will be the final output. Circular shift. Now this is another type of shift where the bit that is shifted out is the input of the shift. So in previously we had pushed 0 and the last bit was discarded. What we're going to do over here is we're going to shift the whole data. We are going to shift the entire register. So this bit goes here and this goes here and so on, and the last bit that is shifted out is gonna come and it's gonna be added to the first place. So it's basically like shifting the whole thing one point and moving the last bit to the front. The left shift on the other hand is going to be the same thing but in the opposite direction. So we're going to shift all of them towards the left by one step and the last bit is going to be added towards the front. The notation for circular shift right is CIR, so circular right. The following example will give us the output as follows. So we had 10110111. We shifted the entire number. So if we see from here onwards, the number is the same, 10110111, and then the first bit comes here, 1. So this is the final shifted R3 content. It can be represented as CIR R3, stored in R3 after the changes. If we have circular shift left on the following content, then we are going to represent it with CIL R2 and storing it in R2 after change. The following will be the outcome, where we are going to shift in this direction. So all the bits from this point onwards are the same as from this side, So 111 so 111 and the third bit is gonna go and get added to the front, so we get 4 ones over here, giving us the final content of R2 as this after a circular shift left. Now we come to arithmetic shift. The arithmetic shift is meant for signed binary numbers, or you can say integers. The main distinction is that the arithmetic shift must keep the sign. So whenever an integer has a sign, the arithmetic shift will keep the sign and the sign of the number as the same when it performs multiplication or division. What the arithmetic shift does is it multiplies or divides the number. So when we shift left, it multiplies the number by 2. Okay, it is given by the following notation. We push a 0 to the right side, shift each bit towards the left. The signed bit does not shift, so this is the point where we lose the last bit. Okay, we'll shift the bits, 0 will be put here, and from here the last bit will overflow, and the signed bit remains where it is because it must keep the sign of the number same. The left shift is used for multiplying the number, so it's multiplied by 2. After we perform the shift, the output which we get will be the multiplication of 2 of that number. The right shift on the other hand divides a signed number by 2, so it is given by the following operation. The signed bit, you can see we were pushing a 0 over here. What we are going to push over here is the signed bit. Fine. So we're going to take the signed bit, we're going to push it in from the same side, and hence we have the signed bit already. We'll have another same signed bit over here, and then the rest of it will be pushed out, giving an overflow for the last bit. In the following example, we can see the arithmetic shift left, A for arithmetic, SHL shift left. If we have the register R2, which is 11010, the first one is what represents the sign. So since it's 1, it is a negative number. If it were a 0, it would have been a positive number. And then 1010 is 6. Okay, it is the 2's complement for 6. And after execution of the left shift, we are gonna get the following outcome. So the signed bit stays the same. Okay, 1 as it is. These 4 bits are the ones that are going to change. So we push a 0, so it becomes 0 0 1 0, and then 1 is discarded. Fine. Remember, the signed bit has to stay the same. Okay, this gives us the output of 1 being the signed bit as minus 0100 is 12 in 2's complement. Hence we have the multiplication of 6 times 2 while keeping the sign the same. One thing we need to make sure in arithmetic shift left is that we must check the operation for overflow. This overflow is for the signed bit. So before the shift, the leftmost 2 bits, okay, they have to be checked for overflow. If the left 2 bits differ, then the shift will result in an overflow. Okay, so if this bit is different from this, we have 1 over here and 0 over here, it will cause an overflow. Okay, the overflow flip-flop V can be used to detect an arithmetic shift left overflow, and if there is overflow, that is if V is 1, so the sign reversal will happen. That means if we had 1 over here, then it will become 0, hence the sign will change from 1 to 0. This is because of multiplication. So if we are multiplying it with a different if with the similar signs, so the sign has to change, and that's how we determine overflow. If V is 0, then there's no need for overflow, and to test that we do the XORing of the leftmost 2 bits. The arithmetic shift right is done as follows. This is the division. We again have the same number 11010, which is 6 in 2's complement with a negative sign. After performing the operation, what we're going to do is we're going to take the signed bit and we are going to push it into the content. Hence we have the signed bit repeating again, and then we have the code continuing from 101, and the 0 at the end is discarded, and hence we finally get minus 6 in 2's complement from MSB1 showing the negative number, the most significant one, giving us the negative number, and we get 1101 as 6 in 2's complement. This here is a brief table for the shifting operations. We have shift left, we have shift right, circular shift left, circular right, arithmetic left, and arithmetic right. Thank you and see you in the next topic.